Okay, so my name is Natalia Casariel. I'm going to be starting my presentation by first discussing the different types of blood. So our body has type A, type B, type AB, or type O. Blood is determined by the presence or the absence of antigens. Type A blood would have antigen A, type B would have antigen B, type AB has both antigens A and B, whereas type O has neither. Another determining factor would be the presence of the Rh protein on our red blood cells. So Rh protein is present, the blood type would be positive. If it is not present, it would be negative. This would allow for a separate set of blood types such as A positive, A negative, B positive, B negative, so on and so forth. Our body would produce antibodies against an antigen that we don't possess. So that means basically if you are type B, if you were to get a transfusion of type A, then the body would not recognize the type A antigen, would consider it a foreign body, and therefore create antibodies to attack. So a mother who has Rh negative blood and has a fetus with Rh positive could potentially make antibodies to attack the foreign blood or the fetus's blood. This typically isn't an issue with the first child because the blood doesn't usually get mixed until the end of the pregnancy during labor and delivery when the placenta detaches from the mother. It could potentially happen sooner if the mother was to have an injury to the abdomen, such as with a fall. This can also happen if there's a miscarriage or an ectopic pregnancy. So basically, once the mother's blood comes into contact with the baby's blood, it would start to create antibodies to attack that Rh protein that the mother's blood considers foreign. So with that second child, if the second child is also Rh positive and she did not receive any treatment to prevent her from making antibodies, then her body would recognize that fetus as having something foreign and would thus attack its red blood cells. This would be considered the Erythroblastosis Fetalis, or would be considered an Rh hemolytic disease. So if you break down those two words, it gives you a better idea of what we're talking about. So hemo means blood, lytic or lysis is breakdown. So it's literally the breakdown of blood. And then if you look at erythroblastosis fetalis, erythro meaning red blood cells, blast being immature, not fully developed, and then osis being the state of or the disease condition. So basically, you're looking at a fetus that has a disease condition of immature red blood cells, or the breakdown of the immature red blood cells. So when this happens, when the mother's body attacks the fetus, the red blood cells are broken down in the fetus, thus resulting in the child having anemia. This would result in the fetus having tachycardia. They would have shortness of breath, issues with fatigue, not having enough oxygen throughout the body. It would also typically result in the child having jaundice. The liver would have to deal with breaking down all of those red blood cells, and thus there would be an increase in bilirubin. This results in the child having inside the womb a yellow color to the amniotic fluid, and after delivery, typically a yellow discoloration of the skin and the white part of the eyes. If there is a high level of bilirubin, it could even result in brain damage and seizures. So typically treatments would involve bilirubin lights and worst case scenarios, transfusions. If it's monitored closely and during the pregnancy known, they could do transfusions of blood while the child is in the womb and potentially deliver the child early once the heart and the lung are developed. So now if we're able to do the proper treatment and mother knows when she's having her first child that she's Rh negative, then what would happen is they would give the injection of Grogan, which that basically is a immunoglobulin antibody that would be intramuscular injection shot, that would protect the infant by targeting the Rh protein in the mother's blood and basically kind of shielding it or stopping it from being noticed by the mother, so that way she never produces antibodies to attack the Rh protein. So as long as she gets that injection, the mother would never produce the Rh antibodies to harm the fetus. Usually they want to give this shot at 28 weeks in the second trimester. The shot is typically good for 12 weeks. That would get them to the end of the pregnancy. And then after the child is delivered, they would once again give another injection of the RhoGAM. The purpose of that is to basically protect any future fetuses or children. If the baby's blood did get mixed in with the mother's blood, it then would just be an extra protection to make sure that the mom never creates antibodies. Because once the antibodies are made, then the RhoGAM shot is not going to be successful. All right. So that is my presentation, and I hope you enjoyed.